Hi everyone, I am Rajdeep Sarkar and pursuing my graduate degree from Mathabhanga College in Chemistry Honours. Today we are going to discuss about the Diels Alder reaction. What is this Diels Alder reaction? This Diels Alder reaction is a type of pericyclic reaction. Pericyclic reactions are the group of reaction where the electrons are delocalized or rearranged. For example, the pi bonds can be rearranged into sigma bond, otherwise the pi bond can be delocalized. In this way, the electron delocalized or rearranged initiated by the supply of energy. So the Diels Alder reaction is one type of pericyclic reaction, and today in this video we are going to see how the reaction takes place and how the product is going to be formed. Requirement: this reaction is going to take place in a conjugated diene. At first, for this reaction you need a conjugated diene which have a conjugated double bond and a dienophile. Dienophile is a compound which can attack the diene. Apart from this, we have to supply the energy. We can supply the thermal energy or photo energy. And now the reaction takes place and the cycloaddition product is going to be produced. Now let's see how this Diels Alder reaction is actually happening. Here you can see these 4 pi electrons and these 2 pi electrons are involving this reaction. For this we are calling this 4 plus 2 cycloaddition reaction. This is a concerted mechanism, means we are getting the final product in just single step. So let's see how we are getting the final product. For this reaction, this pi electron is trying to move here, and when this pi electron moves, here a valency is created. To satisfy this valency, this bond is just moved here. So a new sigma bond is created. When this pi bond is moving, here a valency is created. To satisfy this valency, this pi bond is just delocalized. When this pi bond delocalized, here a valency created. To satisfy this valency, remember the first electron was trying to move, is just come here, and a new sigma bond is happens. Thus we getting the final product. This is another example of Diels Alder reaction. The mechanism of this reaction is as simple as the previous one. When we are supplying enough heat, this bond breaks, and here a valency is created. To satisfy this valency, this bond interacts with this carbon, this bond is interact with this carbon, and a new sigma bond is created. When a new sigma bond is created, here a valency is created. To satisfy this valency, this pi bond is just delocalized. When this pi bond delocalized, here a valency created. To satisfy this valency, this bonds is just going to interact with this carbon, and a new sigma bond is created. Here you can see this pi bond converts to a sigma bond, and this pi bond is also converts to a sigma bond, and this pi bond is just delocalized. Now we are getting this final product. Now let's talk about the factors affecting the Diels Alder reaction. Here you can see we are taking a simple diene and a simple dienophile. In 90 to 95% case, diene always donates electron. So diene should be electron rich and the dienophile should be electron deficient. We can increase the electron richness of the diene adding a electron donating group, as well as we can increase the electron deficiency of a dienophile with adding a electron withdrawing group. The more electron richness of the diene and the more electron deficiency of a dienophile leads the reaction to a faster process. Now let's look at the factor number 2, the cis and trans form of the dienes. The dienes should be always present in cis form for the Diels Alder reaction. The trans form of the diene would not able to react in Diels Alder reaction. Now let's look at the following example of this diene. Which of the diene will react in Diels Alder reaction? Here you can see this diene is in simple cis form, so this diene will react in Diels Alder reaction easily. But here you can see this diene is present in the trans form, but here the rotation between these single bond is possible. If this single bond rotates, the diene converts to the cis form of the dienes. So this diene can react in Diels Alder reaction easily. But here you can see the diene is present in the trans form. but in this around this single bond the rotation is not possible, and the diene cannot convert to the cis form. For this reason the diene won't react in Diels Alder reaction.